This new unit we're going to start is called trigonometric functions. And so we're going to start with looking at angles. And we need to talk about the measure of angles and the units of measure called radians and degrees. Now back from geometry, you learned how to find the circumference of a circle and probably the arc length as well. So for this circle, find the length of arc AB. Now what am I referring to? Well, that refers to this curved portion of the circle from A to B. Well, notice that's just a fraction of the entire circumference. So we need to figure out a fraction of the circumference of a circle, and the formula for that is 2 pi r. 2 pi times the radius. So what fraction of the circle are we dealing with? Well, an entire circle is 360 degrees. And we're looking at only 120 degrees out of those 360. So we want that fraction of the circumference. Now that fraction reduces down to 1/3, and we can plug in the radius for this circle is 6 inches. And so that gives us 4 pi inches. It's a linear measurement, so it's just inches. So a little more than 12 inches if we multiplied it out on a calculator. All right, what if we want to find the area of sector AOB? Now, what's a sector? Well, a sector refers to the pi wedge here, the area inside there for that piece. All right, so it's the same idea. We know the area of a circle is pi times the radius squared. Well, we want a fraction of the entire area of the circle. So just like we did with the arc length, what fraction are we dealing with? For this example, 120 degrees out of 360 degrees, or 1/3. And our radius is 6, so 6 squared. 36 divided by 3 is 12, so we get 12 times pi, or around 37-ish, and this would be inches squared because we're dealing with area. All right, so arc length and areas of sectors are just fractions of what you've calculated in geometry for circumference and area. So what is a degree? And for that matter, what is a radian? Well, those are just measures for angles. Just like for linear measurements, we have inches and we have centimeters. So we have different units depending on which would be more appropriate for the situation. 1 degree is what fraction of an entire circle? So an entire circle is 360 degrees, all the way around, 360 degrees. So 1 degree would be 1/360th of a circle. On the other hand, what about a radian? What's 1 radian? So in terms of, here, let me draw a 1 degree angle here. A 1 degree angle is very, very, very tiny. And that's probably even too big, but that's as small as I can make it. So what about a radian? What fraction of a circle is that? Well, if we're dealing in radians, you probably already have learned that there's 2 times pi radians in 1 complete circle. And pi being about 3.14. So that's about 6.28 radians make up a circle. So 1 radian is 1 over that 6.28, or I'll leave the exact answer. It's about 1 over 2 pi, so it's a little smaller than 1/6 of a circle. And 1/6 of a circle, I probably made that a little bit too small. 1/6, so cut that into thirds. Yeah, that was probably about right. So about 1/6 of a circle there. So notice that 1 radian is a lot bigger than 1 degree. But most people are familiar with degrees. Like if I say the measure of an angle is 35 degrees, you can picture about what 35 degrees is. But if I say an angle is about 4.2 radians, most people have no idea how big that angle is. So that's what we need to be familiar with. And we'll talk about shortly how to convert back and forth between radians and degrees. All right, let's look at this picture. In this picture, we have an angle which is 1 radian. I probably want to make sure it's clear. That's not a degree. That's 1 radian. And I want to know what's the arc length of the sector of the circle. So what's this length if the radius of that circle is r and the angle is 1 radian? Well, we'll do it just like we did before. It's going to be a fraction of the circumference, and the circumference is 2 pi times r, and r in this case is actually r, and we want a fraction of the entire circle. Well, this has an angle of 1 radian, and in a circle we know there's a total of 2 pi radians. So we want 1 over 2 pi, let me clean this up a little bit, 1 over 2 pi times 2 pi r. And notice, if we do some canceling there, the answer is just r. So the arc length is going to actually equal, and I know it doesn't look like it in the picture, but that arc length will be the same. If that was a piece of string and we held it out and straightened it out, it would be the same as the length of the radius for that circle. And so therefore that gives us this connection that the angle, as long as, and this is important, as long as it is in radians, not in degrees, if the angle is in radians, that angle is equal to the arc length divided by the radius of the circle. And if you know 2 of those 3 measurements, you can always calculate the third. So in general, for a picture like this, the radian measure of an angle is going to be the ratio of the arc length to the radius. All right, let's switch gears. What if we want to convert back and forth between degrees and radians? So the key is to remember, let me write this over here, that 360 degrees is all the way around the circle, as is 2 pi radians. So those are equivalent. All right, so I want to convert this. I have 2 pi over 5 radians. Now that's an expression. It's not an equation. So the only thing I'm allowed to do with an expression is to multiply by a form of 1. And so let me multiply, and this, you might have done some dimensional analysis, so it's the same idea here. I want to get rid of radians, so I want to put radians in the bottom of my fraction, and I want to put degrees in the top of my fraction. And I know that 360 degrees is equal to 2 pi radians. Now I guess I could have reduced that. So I could divide both those by 2. And so I can just write 180 degrees is equal to pi radians. Those both represent halfway around the circle. And now if I do some simplifying, the pi's here will cancel out. 2 times 180, 360 divided by 5 is 72. And now my answer is in degrees because my radians canceled out as well. What if I wanted to do it the other way? What if I had degrees and I wanted to convert to radians? Same idea. I have 320. I'll just write the word degrees instead of the symbol. And I can multiply that by a form of 1. Now I want to cancel out my degrees. So in my fraction, I'll put a degree in the denominator this time. And then the numerator, I'll have radians. And I know the conversion is that pi radians is equal to 180 degrees. So now my degrees are gone and my answer will be in radians. So I have 320 pi over 180. And I can simplify that, 32 over 18, or 16 pi over 9 radians. So 320 degrees is equal to 16 pi over 9 radians. So the important thing to remember when you want to convert back and forth with angles between degrees and radians, that pi radians is equal to 180 degrees. So you're going to multiply by either pi over 180 or 180 over pi. Oops. There we go. 180 over pi or pi over 180, depending on what you want. So if it's given in radians, you want the radians to cancel, so the radians will be in the denominator. If you're given degrees, you want the degrees to cancel, so degrees will be in the denominator. Let's convert two more. Convert 2/3 radians to degrees. So now these are a little unusual, and by not having a pi there, it makes it seem a little different, but it's really the same process. These are radians. We want to get rid of radians, so where does that go? Goes in the denominator. Degrees goes in the numerator. 180 degrees is equal to pi radian, so I'm multiplying by a form of 1. So now my radians are gone and my answer is in degrees. And so that gives me what? 120 over pi degrees. And we can just put the degree symbol there. And we're not used to seeing an angle measured like that, saying, oh, 120 over pi, but realize that's, what, somewhere close to 60 degrees? All right, how about one last one? Let's convert this to radians. So these are in degrees. Don't let it fool you that there's a pi there. We have a degree symbol here. So this is in degrees. So if it's in degrees, we want to cancel the degrees, so that goes in the denominator, and pi radians will go in the numerator. So now my degree units cancel, and my answer is in radians. In this case, the pi's there will also cancel, and we get 4 over 180, which is 1 over 45, I believe, radians. So 4 over pi degrees is about 1/45 of a radian. Now remember, we learned what a radian was earlier. That was about 1/6 of a circle. So, and 4 over pi degrees, 4 over 3.1-ish. So that's a little bit more than 1 degree. So that's, you know, visually, if you think of what those angles, if you can picture what those will look like, that makes sense. All right, what if we wanted to further break down degrees, just like inches? You know, we could break down into half inches, quarter inches, eighths, or centimeters, we could break down to millimeters. Well, for angles, if we're dealing with degrees, we can further cut that down into more precise, smaller units called minutes and seconds. And so, if we have 1/60th of a degree, that is equal to what we call as 1 minute. So 1 minute is a 60th of a, if you took 1 degree and cut that up into 60 evenly sliced pieces, each one of those would be referred to as a minute. That's a measurement of an angle. And then if we took each of those minutes, if we took one of those minutes and we cut it into 60 equal parts, which are going to be really, really tiny, each of those angle measurements are called seconds. So degrees, minutes, seconds. The nice thing is minutes and seconds reminds you of time and a clock, and we know that there's 60 seconds in a minute and 60 minutes in an hour. So you can kind of think of a degree as like an hour when you're converting to minutes and seconds. All right, so let's do a couple of conversions on these. Convert to degree. So this is read as 76 degrees, 35 minutes, and 15 seconds. We want to convert it just to degrees using decimals. So what we do is we start with the smallest unit. The smallest unit are my seconds. 15 seconds. So I know that 15 seconds is 15/60ths of a minute. So I have 35 minutes plus 15/60ths of a minute. And then we have the 76 degrees. So using a calculator would probably make life a lot easier. 15/60ths happens to be 1/4, so that's 0.25. So I could write this as 35.25 35.25 minutes, 76 degrees. And then 35.25 minutes is what fraction of a degree? So that's 35.25 sixtieths of a degree. So see what, let me draw an arrow. So what you do is first you take your seconds and convert it into minutes. So now 35 minutes and 15 seconds is 35.25 minutes. And now I'm going to take this 35.25 minutes and convert it to degrees and add it to the 76 and get my final answer. And at this point, let's just use a calculator. 35.25 divided by 60, 0.5875, and then I'm going to add 76 to that. Oops. See if I remembered that correctly. $58.75, yeah. So 76 degrees, 35 minutes, 15 seconds is the same as 76.5875 degrees. If we just use a calculator from the beginning, I guess we could just punch it in this way. 76 plus parentheses 35 plus 15 divided by 60, close that parenthesis, divide that by 60, and there you go. All right, let's try another one. What if we convert the other way? Let's convert 124.58 degrees to radians. So we know that it's 124 degrees. That's the easy part. Now we have to figure out what is 0.58. So if I multiply 0.58 times 60, I want to know what is 0.58 of 1 degree. And we know that there's 60 minutes in a degree. So what's 0.58 of 60? $34.8. So I've got 124 degrees and 34.8 minutes. Now I want to take that 0.8 and I want to know 0.8 minutes is how many seconds. So I have 124 degrees, 34 minutes, and whatever 0.8 times 60, well, that's 48 seconds. So in this case, when you're converting the other way, just take the decimal, multiply it by 60, that gives you the minutes. Take any decimal from that part, multiply it by 60, and that gives you your seconds. So it's pretty easy. There's also a conversion function on the calculator that'll convert to degrees, minutes, seconds for you. One last type of problem. What if I asked you to find the measure of angle B? You know, this would seem like a geometry problem if the angle here was in degrees, but it happens to be in radians. But that's not a problem. What do you remember from geometry? All the angles in a triangle add up to what? 180 degrees. Since it's a right triangle, that means the two acute angles must add up to 90 degrees. Well, we're dealing in radians, so there's two ways you can go with this. We could convert this to degrees and then get our answer. But since the original problem had our units in radians, we probably want to give our answer in radians as well. So then you'd have to convert back after you figured it out in degrees back to radians. That seems like way too much work. So let's convert 90 degrees as how many radians? Well, 90 degrees is a quarter of a circle. And we know that there's 2 pi radians in a full circle. So 90 degrees, I didn't mean to write that. So 90 degrees, or 1/4 of that, is going to be pi over 2. So all I'm going to do is I'm going to say pi over 2, which is 90 degrees, minus the pi over 8 angle, and that'll give me angle B. So if I get a common denominator, make this 4 pi over 8, we get 3 pi over 8. So the measure of angle B is equal to 3 pi over 8 radians. So you should be able to convert back and forth and do problems that deal with angles in radians and also in degrees. All right, one last idea talks about angles in standard position, so putting them on the coordinate plane, and coterminal angles. So what if I asked you to sketch each angle in standard position? 60 degrees, negative 100 degrees, 420 degrees, and negative 300 degrees. In geometry, we didn't talk about negative angles, or angles actually that were more than 180. So how do we sketch these? Well, what we're going to do is we're going to start on the positive x-axis, and that's called our initial side of our angle. And then 60 degrees is about right here. And so that's the terminal side of our angle. Negative 100. So our initial side is the positive x-axis. This time though, instead of going counterclockwise, we're going to go clockwise. So 90 degrees, boom. A little bit past negative 90 there. There's negative 100 degrees. 420 degrees. Okay, so here's your initial side. So let's start going. That's 90, that's 180, that's 270, that's 360, and then we still need to go another 60 degrees. So that would be where 420 would end up. How about negative 300? Initial side on the positive x-axis. We're going to go clockwise because it's a negative angle. So we go negative 90, negative 180, negative 270, and we still need another 30, so about there. And there you go. Now you may have noticed these all seem the same. Talk about that in a second. So the initial side will coincide with the positive x-axis. The terminal side is formed by rotating that initial side counterclockwise for positive angles, and then just clockwise for negative angles. And you'll notice that 60 degrees, 420 degrees, and negative 300 are called coterminal angles because they terminate or they end at the same spot. So if I put these graphs on top of each other, it would look like we drew out the same angle for all three of those, which lends itself to the next question. Determine two coterminal angles, one positive and one negative, for 3 pi over 4 radians. Now, Ed, the more you work with radians, the more comfortable you will be drawing those angles in the coordinate plane. And so, at first, if you need to convert to degrees, you can do that and then convert back. But I'm just going to go ahead and... Now, 3 pi over 4, I know that pi over 4 is 45 degrees. And 2 pi over 4, or pi over 2, is 90 degrees. And 3 pi over 4 is right there, and 4 pi over 4 would be equal to pi, which is half of a circle. So here's 3 pi over 4. Draw that in green. There's 3 pi over 4. All right, so we want to wind up in that same spot. So what do we do to get there? Well, look what we did in these problems. How did I get to the, let's draw an arrow, put blue out. How did I get to the 420? Well, notice that I went around one complete time, 360, and then another 60. So basically I added, from here, I added one full circle to get back to that same spot. So I added 360 degrees to that. How about for this negative one? What did I do? Well, it's the same. Instead of going counterclockwise a full circle to get back here, how about if we go clockwise, which is the negative angle direction, one full circle. So if I subtracted 360, I would get to that spot, which is right there. So, let's jot that down. So when I had 60 degrees, if I added 360, that's one more full circle around, I got to 420, and that was the same angle. And if I subtracted 360, or a full circle, I got negative 300. So those were all coterminal angles. So I want to do the same idea for any of these types of problems. Wherever we're at, we're going to want to add one full circle. If it's in degrees, that's 360. If it's in radians, you're going to add 2 pi. And if I want to go the other way, I would subtract a full circle. If you're in degrees, that's subtracting 360. If you're in radians, it's subtracting 2 pi. So it's really quite simple. It takes more time to explain it than actually to do it. So I'm going to do 3 pi over 4 plus 2 pi. And 2 pi over 4 is the same as 8 pi over 4, so that gives me 11 pi over 4 radians. And that's a positive angle. And then if I subtract 2 pi over 4, that would be subtracting 8 over 4, so I'd get a negative 5 pi over 4. And so there's my negative angle. And I could keep subtracting 2 pi, I could keep adding 2 pi. So this says determine 2 coterminal angles. I could keep going, and there's a lot of different answers. I could just keep adding or subtracting multiples of 2 pi and get as many as I want.